Hello kids, in today's video we are going to talk about the first chapter only, that is Matterinoursurroundings, and we will be taking in detail the change of state of matter and latent heat. Before that, begin with the inspirational thought which says that a little progress each day adds up to a big result. So keep on taking those small steps. Beginning with our topic, whenever we think about change in state of matter, we always think that where can we observe those small state of this change of state of matter. So there are several examples which are around us, like melting of ice is there, evaporation of water from water bodies, making of dry ice. We can observe the formation of clouds in the sky, the formation of snow in the upper layers of atmosphere. We can also observe melting of ice creams. We can also observe the formation of steam when the food is getting cooked in the pressure cooker. So there are several steps other than this where the change of state of matter can be observed. Correct? So when we talk about the next thing, that which factors are basically responsible for change in state of matter. So they are broadly divided. There are two factors which are mostly responsible for change of state of matter. First is change in temperature. Second is change in pressure. Correct? So we'll be talking in these two factors in further detail. So let's take a question that what happens when a substance is heated? When you heat some substance, what exactly happens at the time? So these are the steps or the things which happen. First, whenever any substance is heated, the particles of that substance, either the atoms or the molecules, they absorb the heat. And when they absorb the heat, the kinetic energy is the energy by which allows the movement of molecules, which is due to the movement of molecules. So whenever the particles or the molecules or the substances of that matter absorb heat, they start vibrating at a more higher speed, or they start moving at a higher speed. If it's a solid, the particles can only vibrate in the beginning, and later on when it turns into liquid, they can move at a more higher speed and to a greater distances. Next thing, that on absorbing sufficient amount of energy which is required to overcome the forces of attraction, like when you talk about when you're heating any solid. So solid molecules, we are aware that they are very compactly packed and they have a strong force of attraction between each other, correct? And that some energy is required to break those forces of attraction. So this energy, in which we are giving in the form of heat, is absorbed and is used in overcoming those forces of attraction. So when the molecules has absorbed sufficient amount of energy to overcome these forces of attraction, what happens? They start moving away. So the particles start moving freely. So this liquid, so the solid, once the particles have overcome force of attraction, they are free to move around. That means the solid, at this stage, the solid changes into the liquid, correct? And the solid substance has changed into liquid state, from solid to liquid state. Now, if the constant heat is given, that means if the molecules will be given constant heat even after this, then what will happen? The liquid molecules will again continue to absorb heat and will finally break those forces of attraction and will change into gaseous state of, correct? Gaseous form or gaseous state. Now, observe this. Whenever this I have, you can observe here, if you have taken a liquid, if you take any liquid and you heat it, then what happens? When you keep on observing, when you keep on giving heat to this liquid molecules, the molecules will absorb the energy. The molecules will absorb the energy and will start vibrating. The molecules will start vibrating, correct? And the particles will start moving at a higher speed, will collide with each other, and if the heat is constantly given, like you can see here, the molecules have started, has absorbed the heat and they have started vibrating, colliding with each other and absorbing sufficient amount of heat. They are changing into gaseous state and they are moving out of that liquid. Like if you're heating it in a beaker or a bowl, so they will break away from their that liquid state and will become gas. So this is the way the molecules of a one state changes into another on absorbing the heat, correct, or on increasing the temperature of any substance. This is the way in which the state of matter changes, correct. Now, we have already observed that there are several processes which we have named for the state of change of matter. The common example which we can take is of ice, water and water vapors, which we can observe in the nature also. Like, correct? So when we talk about ice, you're aware that normally the water at room temperature, the water is present in liquid state, correct? And when that water is cooled down, either at artificial conditions, that means in the factories or in the houses, in the freezers, or on the mountain peaks. So when when the temperature becomes less than 0 degree or 0 degree, the water changes into ice, and that phenomenon is called as freezing, correct? And when the ice is as the temperature increases, the ice can change back into water, and the process is called melting or fusion, correct? These are the same synonyms used as a synonyms. That means both the terms can be used. Fine. When the water is heated up, then it can change into water vapors, and the process is called as evaporation. And if the water vapors which are formed cool down again and change into water, that process is called as condensation. And sometimes you would have seen that this happens whenever this change is very common in nature. That means when you are seeing the clouds forming, you can observe the snowfall in some parts of the world also. So this is very common phenomena where the change of state of matter is very visible and can be easily understood. Fine. So whenever we talk about change in state of matter, we are saying that this is associated with the kinetic energy. Kinetic energy means the ratio by which the molecules can move around, correct? So whenever we talk about ice, or whenever we talk about any state of solid state material, then we will say that the solids have the lowest kinetic energy. Fine. And as the states of matter changes to liquid and then to gas, the kinetic energy constantly increases, and as this kinetic energy will increase, the states of matter will keep on changing. Fine. Moving on further, it comes to our mind that yes, okay, fine, the solid is changing to liquid, liquid is changing into gas, but there is a fixed temperature at which a substance changes from solid to liquid or from liquid to gas, correct? So yes, there is a fixed temperature for different substances at which they change from solid to liquid and from liquid to gas. Fine. So let's understand this, that temperature at which the substance changes from solid to liquid, that is called as melting point. Okay, so that temperature is called as melting point, and the melting point of ice is, in common terms we say that it is 0 degree centigrade. And in science, whenever we're talking about the scientific phenomena, we use the unit Kelvin. So in terms of Kelvin, it is 273.15 Kelvin. That means the 0 degree is equal to 273 Kelvin. Fine. So whenever we talk about this melting, hopefully you will be clear about it. Fine. And remember, different substances have different melting points. You can easily understand that water can change from solid to liquid at 0 degree, whereas you cannot imagine that the iron will change into liquid iron at the 0 degree or at 10 degree or 20 degree. So different substances have different melting point, and this is also one of the method by which they are separated from their odes and from their mixtures and all those substances, correct? Okay, now what does this having high melting point shows? Like I discussed that iron will melt at a very high temperature. Iron cannot melt at a 10 degree, 20 degree or 50 degree or 100 degree. Fine. What does this high melting point indicates? Fine. So this high melting point indicates that the molecules of that substance is having very strong forces of attraction between them. And when they have a very strong force of attraction, it will take so much of energy to break those forces. Fine. And that is the reason that those substances will have very high melting point. and similarly high boiling point as well. Fine. So remember, whichever substance is having high melting point, that means they are having very strong forces of attraction between their particles. Fine. Moving on further, whenever we talk about latent heat of fusion, whenever we talk about change of any substance from solid to liquid or liquid to gas, we observe a phenomena that whenever it is changing from solid to liquid and from again at a stage from liquid to gas, there is a temperature there is a temperature at which the even if we are giving constant heat, the temperature does not rise, which I've shown you in the graph here. You can observe that even, for example, we have taken ice at which is like -10 or -20 degree, fine, or any substance which is at -20, fine. Now on heating that substance, you can observe that this is an area where the constant heat is being given, but there's no change in temperature. We have taken the temperature on this axis and heat given on x-axis. So you can understand that for some time there is no change in temperature. Now the question arises that we are constantly giving heat. Where is that heat going? That heat has actually hidden. Fine. And the latent word is the Greek word of that. That means this latent word is derived from the hidden word. That means actually this latent means hidden only. Fine. So what this latent heat of fusion is, that this heat which is being absorbed during this time when there is no change in temperature. So this heat is actually being used up in overcoming the forces of attraction between the molecules. So this is a phase at 0 degree temperature where there's no change in temperature, but the heat is being constantly absorbed. Fine. So this is, while heating a substance, the temperature remains same for some time, and that at that time the energy is being used up in overcoming the forces of attraction between the particles of that substance. We have taken here the example of ice, water and water vapor, change of these, but you can take it in case of any substance. Fine. And what is this latent heat is defined as? This latent heat is defined as a heat energy which is required to change 1 kg of solid into liquid at room temperature at its melting point. Fine. That means we are neither changing the temperature of surroundings. This happens at the melting point of that substance. Fine. For ice, we say that it happens at the 0 degree. At 0 degree, this thing happens. This happens at 0 degree. Fine. So this heat which is absorbed for changing the state of matter, and during that change of state of matter, when the heat is being absorbed in overcoming those forces of attraction, this heat is called as latent heat of fusion. Correct? Moving on, what happens if the liquid is constantly heated up? Fine. Now, a solid has changed into liquid. And what will happen if the liquid is heated up? Fine. So, when the liquids are heated up, again the same thing will happen. The molecules will keep on absorbing the energy, and they will, as their kinetic energy has increased, so they will collide with each other. They will move at a very higher rate, and whenever they have absorbed sufficient energy, or they have sufficient kinetic energy, they will break those forces of attraction and will break free from that liquid and will mix with the atmosphere, or will change into a gaseous form. Fine. So this is what happens. Now remember that again we are talking about that just like a substance melt at a particular temperature, that means it changes from solid to liquid at a particular temperature. Similarly, it also changes from liquid to gas at a particular temperature, and that temperature is called as boiling point. Fine. So we are aware that the boiling point of water is 100 degree. That means at 100 degrees centigrade, the water will start boiling, and at that temperature, what happens? they will be huge, or they will be bulk, or there will be a huge number of particles of water will change from liquid into the vapor form. And that's why you can see whenever your mama will be boiling water, or whenever something is being cooked which contain good amount of water, a huge amount of steam comes out of it, because at the same place, in small area, a lot of water vapors are being formed, and that's why you can observe the steam forming. So boiling is a bulk phenomena. Fine. Remember, and boiling point is a temperature at which the very good number of particles changes from liquid to gaseous form. That is from water to water vapors. And boiling point of water is 373 Kelvin. Fine. 273 plus 100 degree, that is 373 Kelvin. And again, this latent heat of vaporization is similar to latent heat of fusion. So, latent heat of fusion was when 1 kg of solid is changing from solid to liquid, and here latent heat of vaporization is when 1 liter of water or 1 kg of liquid is changing into gas at its boiling point. Fine. So whenever 1 kg of liquid is getting changed into gas at its room temperature and it's at its boiling point, it is called as latent heat of vaporization. Fine. Hopefully you will not confuse the latent heat of fusion. Fusion means melting. That means the heat absorbed during melting. Latent heat of vaporization means the latent heat which is absorbed during formation of vapors. That means from liquid to gas. Moving on further, there was a second factor which we said that is mainly responsible for change in state of matter, and it was the change in pressure. Fine. What is pressure? Force per unit area. That means how much force is applied in a per unit area. And we've also studied about the atmospheric pressure which we all are facing because of the atmosphere above us, or the layers of air which is above us. Fine. So this pressure also plays an important role. It can be the natural atmospheric pressure, or it can be the artificial pressure created for bringing out some change. So whenever we have to, how this pressure plays a role. Whenever we apply pressure on a container which is having gas in it, what happens? As you can see, we are applying pressure here. So whenever the pressure is applied on a gas, the molecules have less space and they are compressed, and whenever you compress a gas, it changes into liquid, and if the liquid is compressed further, it changes into solid because there is no space. Whenever we are compressing something, we are trying to fit it into a very small space, and that is the reason that whenever the liquid is compressed, it changes into, or when the liquid is applied, when the further pressure is applied on liquid, it changes into solid. Fine. And the example which we can take is the simple dry ice, the solid carbon dioxide which is called dry ice. Fine. So what happens whenever this dry ice which is required for some industrial purposes, so what happens for that we produce the carbon dioxide, we compress it, change into liquid carbon dioxide, and from liquid we further compress it and we also reduce the temperature, correct, and we convert into dry ice. So here both the factors are playing a role. We are not only putting a pressure, we are also reducing the temperature. So you can understand that these are the two major factors which play a role in change of state of matter. That is, number one is change in temperature and second is change in pressure. And if we summarize it, the latent heat is again of two types: latent heat of fusion and latent heat of vaporization. Latent or heat of fusion when solid is changing into liquid, and latent heat of vaporization means when the latent heat required when the liquid is changing into vapor state. Fine. That's it for today, kids. If you have any question, you can leave in the comment. If you like the video, hit the like button, and if you like the video, you can subscribe to this channel also, because I will be making further such videos which will be helpful for you. And thank you for watching. Take care. Bye.